So we made it to Cristacurva, and a huge motivating and driving factor for coming down here is that so often we see these beautiful finished projects and products in Architectural Digest and newspaper, but rarely do we get the chance to go in-house at an IG fabricator's facility and see what it looks like to receive that annealed float glass and process it, cut it, treat it, curve it, apply specialty patterns to it. So that's my goal for coming down here, be able to show you the process behind the scenes, introduce some of the professionals, and give a better picture for some of the magic in the facades we always feature. All right, so we're on the plant floor. I got Javier right here, and we're gonna walk through the entire process. But Javier, tell us, what are you most excited about to show everybody? Which step of the process?
Oh boy, cutting the glass. That's very interesting because you're moving these big sheets and how they get moved. They're heavy, they're big, it's glass, so you know glass is fragile, it could break. And how the machine brings it to the table, how they cut the glass. So that's always something pretty interesting. After you cut the glass, the edges are sharp. They're also not very good looking. So what we need to do now is treat the edges to the either seaming, grinding, or polishing. We most of the time polish the edges here.
So after they treat the edges of the glass, we're actually going to go to the heat treating process, whether it's heat strengthening or tempering. But Javier actually told me that if you do need a silkscreen pattern or to digitally print on the glass, that actually happens before the heat treatment. So why is that?
Correct, yeah. We use this very beautiful machine to print. We use this one or silk screening or roller coating also for spandrel application. And what we use as paint is strip. This ceramic-based paint is basically crushed glass with a pigment. That crushed glass with a pigment, which is called frit, that it gets applied and it has to get fused with the glass. And for the fusing to happen, you have to have temperature. That temperature is tempering temperature or heat strengthening temperature or the curving temperature. That temperature is what fuses the frit onto the glass.
You see we have a lot of actually curved pieces of glass before they assemble into an IG, but talk us a little bit through the process about obviously why the units need to be curved before they're tempered and what we're about to see.
After the glass has been polished, cut, polished, and printed, in case it needs to be printed, we either go to flat tempering or curved tempering. So we have to curve and temper the glass before it's gonna be laminated.
And this is something we've talked about in the past in terms of where the low-E coating is placed and how you're actually laying the unit in the curving process. So how does that work? Obviously, you want to avoid having any contact of the coating with any surface.
You don't want the low-E coating touching any surface, even though it happens in many cases. Sometimes you have to embed the coating with the interlayer, but nothing happens to the coating. Really, you want the coating to be in touch with the air so that it performs the best. And eventually they're going to meet at the end of the process to finish the IG unit that is going to get put into the window in this building.
Piece of glass starts as a flat sheet of float glass, and when the glass goes through the bending furnace, it softens and it slumps into a mold. But at that point, that's where the curve is formed and the geometry is symmetrical. Both the edges are equal because you started with a rectangular piece. But if your final shape calls for one side to be shorter than the other, that cutting has to happen before any heat treatment. So once the glass is tempered or heat strengthened, you can't cut it or modify it. That shape is locked in. So the sequence matters. You have to cut it and shape the flat glass first, then you bend it, then you heat treat it.
So we're actually watching from the outside. I'm going to show you behind me them doing the laminated process where, to put it simply, they're basically making a glass sandwich. And I see they're wearing some uniforms that it doesn't look like we have access to. So what is the actual cleaning process to ensure that you get a clean substrate prior to creating the sandwich?
We have special conditions in this room for the lamination process. We have to be very disciplined. We have to clean it very deeply once per week, but every single day we are cleaning it.
They're cleaning the substrate on the inner side.
They are cleaning right now the surface of the glass before they put the interlayer over the glass. So we can remove all imperfections, adhesive residue like dust, every kind of contamination.
So I think part of what's most surprising to me about this whole process is how meticulously careful every step of the process is, and how, you think about an IG and how sensitive it is to damage, abrasion, scratches, etc. But think about actually creating that hermetic seal, perfect perimeter seal, keeping the gas fill within the cavity, making sure the substrates are clean, making sure you're getting proper adhesion. So one theme that I'm noticing all along the way is it's just such incredible craft and attention to detail to make sure that every step of the process is perfect, because once you create that perimeter seal, there is no going back. So here we're looking at the peaks and valleys while the units are going to go through the tempering oven. So Claudia is showing us the unit in 3D, showing all the various conditions.
This is the scanner where you can see all the distortion values. Those parameters in red are the ones critical to us. We have to be looking every time for these values. Of course, you will not see the glass like that. That will not be visible. You can only see it with the scanner. This is the butterfly test or paper test, but butterfly test is how our supplier call it. This is a very important test. We have to do it daily basis.
So for the secondary seal, you always use a 2-part, not a 1-part.
Yeah, composite of 2 parts. The base
And the catalyst.
The base and the catalyst. We have to do it because we want to be sure that the mix is well done. The proportion with the base and the catalyzer is well done.
So how often are you guys doing this? Every morning or every time?
Every start of the shift.
I have so much gratitude and appreciation for everybody from the Cristacurva team, from the All Things Facades team for participating and creating the opportunity to make this documentary, being able to go behind the scenes and show all of this raw footage, get to know everybody, show the different personalities, and bring this experience to the forefront, being able to show truly what happens behind the scenes, behind all this amazing, transparent, fabricated architectural glass. So thanks everybody, and I can't wait for the next one.